Example 2. The mean of a normal probability distribution is 160 and the standard deviation is 10. And here we have to answer three questions again. What is the percent of observations that lie between 150 and 170? What percent of the observations lie between 140 and 180? And what percent of the observations lie between 130 and 190? Now, since we know that the mean is 160, the mean is 160 and the standard deviation is 10. Let's make a note of that. So in the center of our bell-shaped curve, we're going to indicate that the mean is 160 and that the standard deviation, or the measure of dispersion, is 10 units. Now, we know something about the empirical rule, and the empirical rule says that virtually all of the data, or 99.7% of the data, will be within 3 standard deviations of the mean. So that's mean plus 3 standard deviations and mean minus 3 standard deviations, and 68% will be within 1 standard deviation of the mean. So mean plus 1 standard deviation and mean minus 1 standard deviation. Well, gee, the standard deviation is just 10 units. So why don't we just add 1 standard deviation each time? So we've got 160 in the middle, and mean plus 1 standard deviation will take me to 170. Mean plus 2 standard deviations will take me to 180. And mean plus 3 standard deviations will take me to 190. And I can do the same thing on the other side because the bell-shaped curve, or the normal distribution, is symmetric. So mean minus 10 is 160 minus 10, which will take me down to 150. Mean minus 2 standard deviations will take me to 140. And mean minus 3 standard deviations will take me to 130. So I've got a nice symmetric distribution here, and I want to know what percentage of the values will lie between 150 and 170. So to go from 150 to 170, that's all within 1 standard deviation. So I can say 68% using the empirical rule. 68% will lie between 150 and 170. What percent of the observations lie between 140 and 180? Well, what's 140 and 180? 140 and 180 is within 2 standard deviations of the mean. So mean plus or minus 2 standard deviations means that we're looking at 95% of the data. So 95% of the data is going to be within 2 standard deviations of the mean. And for the last question, what proportion of the observations lie between 130 and 190? Well, 130 and 190, that's within 3 standard deviations. 3 standard deviations of the mean. So what do you know about that? Well, almost all, or 99.7% of the observations will lie between 130 and 190. And in the last question, we're asked what percent of the observations lie between 150 and 180. So, given the fact that we know that the mean is 160 and the standard deviation is 10, and we've got increments of 10 units for the 1 standard deviation differences, so we want to know what proportion or what percentage lie between 150 and 180. So that's a little bit different than what we're used to answering. So 150 is 1 standard deviation below the mean. So that's mean minus 1 standard deviation. Whereas the 180 is the mean plus, let's see now, that's plus 2 standard deviations. So this is mean plus 2 standard deviations above the mean. So what do we know? We know that the normal distribution is symmetric. So what that means is that mean minus 1 standard deviation, this will account for 68% of the data. However, since it's symmetric, we know that 34% will be to the left of the mean and 34% will be to the right of the mean, exactly half of 68%. So therefore, 34% of the data values will be between 150 and 160. And now what we need to do is account for what proportion are between mean plus 2 standard deviations. Now I know that between the mean plus 2 standard deviations and mean minus 2 standard deviations, we can account for 95% of the data values. So therefore, what does that tell you? Half of 95%, or 95% divided by 2, works out to 47.5%. So what that means is that 47.5% of the data values will be between the mean plus 2 standard deviations, and the other 47.5% will be to the mean minus 2 standard deviations. But we don't care about that. We only care about this portion here that's to the right of the mean. So 47.5% will be mean plus 2 standard deviations. So what's the total? The total is going to be the 34% that's to the left of the middle plus the 47.5% that's to the right of the middle, or to the right of 160. And that gives us a grand total of 81.5%. So in other words, 81.5% of the observations will be between 150 and 180.